Good morning, this is Dr. Turner for Integrated Math 3. Today we're talking about 6.2, which is looking at graphing exponential functions. If we were in person, this would be a little more involved. We would be sketching using graph paper, using key features of an exponential function. Because we're doing this online and not in person, we're going to be using Desmos primarily. There are other graphing calculators that you can utilize. You can also use Google Images. So anytime the directions say Desmos, you don't have to use Desmos, but it's the most common and it's what we practice with in class. So you're welcome to use any other graphing software that you see fit, but for our purposes, we'll be using Desmos since we're online, so bear with me here. 6.2 is pretty straightforward, and then when we get into 6.3, we'll talk about it a little bit more. But when we look at the parent function of exponential functions, we start out with what is a times b to the x. If you think back to linear functions where we have mx plus b, each variable has a purpose. X is our input, y is our output, and then in linear functions, m represents our rate of change and b represents our initial value. Now we just talked about how this is slightly different because we're looking at repeated patterns of multiplication or division instead of addition or subtraction in 6.1. So with 6.2, it's kind of the same thing. A represents our initial value, assuming the graph hasn't been translated, it hasn't been moved up, down, left, or right. And then the B represents the rate of change, but we call it a ratio because we're multiplying, not adding each time. Okay. As we've talked about before in 8th grade in Integrated Math 1, when that B value, and you can add the sliders here, that's a nice thing about Desmos, but when that B value is something that is greater than 1, it is a model of exponential growth. It is growth because as x increases, y is increasing as well. It's going up as it goes to the right, if you will. And if b is less than 1 but still positive, then that is a model of what we call exponential decay. We'll talk about exponential growth and decay models in 6.5. Again, this whole unit should be reviewed because you've done these lessons before with Integrated Math 1 and 2. But that's growth, that's decay. Now, when we look in 6.3 and we talk about translating these functions, we're going to tweak it a little bit. Rather than having a very simple parent function, a times b to the x, what we're going to do is we're going to add in the exponent, a minus h, and usually you have to put the parentheticals around it so that Desmos knows that you want the whole thing in the exponent, and then you'll have k on the outside. This should look very similar by now that we're in the second semester of Integrated Math 3. H and k have come up numerous times with absolute value functions, quadratic functions, square root functions, cube root functions. And h and k are going to serve the same purpose that they do for any function family involving h and k, but we'll talk about that a little more specifically when we get into 6.3, which is specifically translating the functions, and it should look very similar to all the other translations we've done throughout the years. Again, if you want to, you can add the sliders and kind of play around with it and see what each of these variables do. H and k, and like I said, we'll cover this a little bit more in 6.3. For now, because we're not really having to graph on paper, if you're asked to graph in 6.2, really you can just use Desmos to do that, or any other graphing utility. So if I have something like 3 times 2 to the x minus 1, just type that in, sketch it, and you can use Desmos to screenshot it. As you're going through 6.2, I encourage you to pay attention to how each of these variables is changing the graph. How is it altering the graph? Is it moving it? Is it dilating it? What's happening to the graph? Because that'll help you in 6.3. But for now, all you have to do is type it into Desmos or another graphing utility and then submit a screenshot for me for these examples. That's all you have to do for 6.2. This video was very brief, but again, we'll cover more details of exponential functions in 6.3, and we'll talk about what those variables do to move the graph. If you have any questions, reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.